Hello, this is Unit 7, Lesson 5. We're looking at solving exponential and log equations by switching from one form to the other. Okay, you're going to need your calculator because the bases or the relationship between the bases and the exponents aren't going to give you whole number or even rational answers in some cases. Okay, so we'll start by looking at exponential equations. All right. Now the method is we'll switch it to a log equation or the log form. Wrong space, sorry. That's just supposed to be a period here. We will use the log form of the equations. And again, just to reiterate the point, to solve an exponential equation that does not have a bases that you can make the same. For example, 2 and 3, we cannot make them into the same base. So you convert these to log form. Isolate the log expression, and then you're going to use your calculator. Okay. Here's what we mean. I'll get to this stuff up here, this change of base, in a minute. All right. So here, remember how we did inverses and what these relationships are. So this is 2 to the x equals 3. Well, in log form, that means log base 2 of 3 equals x. Remember, 2 to the x equals 3. Okay? So now you have log base 2 of 3. Now, if you have a newer calculator, you have a 84C plus, all right, you can just type in math. I'll go up here and do this. So new calc, you type math, or you press the math button, and you go to option A, which looks like this. And when it comes up, you'll just see a place to put the base, and then a place to put the 3, and you press enter, and you get your answer. All right? If you don't have those, that's okay. This change of base rule up here, if you have, for example, log base 2 of 4, now, if you evaluated that, you would get 2 because 2 squared equals 4. Okay? So let's just type in the calculator and see what we get here. So to do this, you'd say log 4 divided by log 2. Now, we should get 2 is the answer. We're doing unknown evaluation to show that that this works. Okay? So you should get 2, and there you go. So it's always the top number, the log of the top number, divided by the log of, not the top number, the log of the result over the log of the base. Okay. So to solve this one with an older calculator, you just go log 3 over log 2. So we go log 3 divided by log 2, and you're done. So let's round to the 100th. 1.58. If you type this in with the newer calculator, you should get the same answer. Okay? All right, if you feel good about that, you can try the next two. Now they get tricky because there might be an extra step. Might be an extra step after this part right here. You might have to subtract or add, divide, something like that. But if you feel like you've got the hang of this, go ahead and try these next two, but I'm going to work through them anyway. Pause the video at any time to try them on your own. Okay? So get this exponential expression by itself, negative 3 to the x equals 35. Subtract 5 from both sides. Okay? So we've got negative 3 to the x. All right, so we want to put this in log form. So that's log base negative 3 of 35 equals x. Now, if you remember from the last lesson, this isn't going to work out. There's no number I can raise this to. I can raise negative 3 to get positive 35. There's no real number. All right? You say, well, what if you divide both sides by negative 1? And you do log of 3, log base 3 of negative 35 equals x. Either way, there's no real answer. You can try either way in the calculator, and it's not going to work. All right, so let's try it. You do log let's try the first one. 35 divided by log negative 3. Enter. Oops. Okay, try it the other way. Log negative 35 divided by log 3. All right, same deal. All right, so I just want to give you an example of one where you're not always getting an answer. Sometimes this is your result. So pay attention to those negative signs, okay? But you'll have the calculator for these, so you'll always be able to have that backup in case you forget about that negative. All right, so let's look at this next one. Okay, let's put this in log form. All right, this is the whole exponent. It's the whole exponent, right? So what that means is log base 25. The base for the exponential function is the same number using the base of the log function. But now it's log base 25 of 144 equals 2x plus 1. Okay? So we've got the log function isolated. You can do your math option A, type in 25 and 144 and press enter, or we do log 144 over log 25 equals, you're still solving for x here, right? The ultimate goal is we're still solving. So I'm going to do all of this. This is all one number, right? I'm going to subtract 1 from both sides, and then I'm going to divide by 2. I'm dividing all of this by 2. Okay, and that'll get us our x value. So you can do all this step by step in the calculator, all right? Log 144 divided by log 25, enter. All right, that answer minus 1, enter. That answer divided by 2, enter. All right, so let's round that to the 100th. You get 0.27 approximately for your value for x that solves this equation. If you tried to graph this, okay, if this was a function, this is where it's going to cross the x-axis, okay? All right, so different ways to look at these, different situations. All right, so now let's look at solving log functions by going to exponential form, okay? So here's our example, log base 3 of 2x minus 5 equals 3. So putting this in exponential form means 3 cubed equals 2x minus 5. 3 cubed equals 2x minus 5. Now, some of these you'll have your calculator, some of these you won't. We hope you guys know 3 cubed is 27. Okay. But if you don't, there's your calculator. So now we're just solving for x. All right. Add 5 to both sides. X equals 16. All right. Now, you should always check for extraneous solutions, just in case. All right. So the way we do it here, we look at this 16 and we look at this part of that log function. If the answer you got for x gives you a negative value inside of that parentheses, it's extraneous. It won't work. We can't get from 3 to a negative number. Okay? But you plug in 16, 32 minus 5 is 27, so we're all good. All right, 16 is good. Okay, go ahead and try that next one, but I'm going to work it out anyway, so you can try it, pause it. If not, I'm going to go through it. Okay, so let's get this log expression by itself. This is ln x minus 5. I divided both sides by negative 2. You can do that. It's no big deal. It's outside of the log. Okay. So, okay, how do we put a natural log in exponential form? Now remember, ln of x is the same thing as log base e of x. So our base is e. So what the saying is e squared equals x minus 5. Now, you will need your calculator for this, right? Because e is not a nice, neat number. So you get e squared plus 5 equals x. So plug that in your calculator. Your e button is the second, and then type the ln. So go second up here. ln, third from the bottom on the left. So it's e squared plus 5. Enter. Okay, we'll round to the 100th place. We're going to get x equals 12.39. All right, so that is solving a log expression just when there's one log expression, or a log equation when there's just one log expression there. Okay, what do we do if we have two? Okay, there's another way to do this. There's properties of log functions or log expressions, but we're not going to do those. If there's time after the last unit of the year, we'll go back and do some of this. But for now, you can just use your calculator and graph them. Okay? So this first example. So basically, this is y1, this is y2. And we're just going to plug them into your y1 and y2 over here. So I get log x plus 5. And then log, negative 5 log x plus 1. Graph. So who remembers what to do here? I got two graphs. I want to solve. Right, we do second calc intersection. Option 5. Just get close to the intersection, whichever curve you're on. Get close to that intersection and press enter. Second curve, get back to that intersection, press enter again. Enter one more time. So solution is negative point, we'll call it negative 0.27. All right, remember we use second calc intersect. All right, how about number 4? Same idea. Type these in, 3 log x minus 3 for y1. y2 is log of x plus 2. Graph. Some of these may not always be so easy to see, but we can tell it sort of intersects there. So again, you really just need to get close on the calculator. We've been doing this. So hopefully this is just a review. So second calc 5 for intersect, first curve. Where'd it go? There it is. Enter. Enter again. Enter one more time. X is 4.904. I'm going to go ahead and round to the thousands place because the hundredth is a 0. All right, pretty straightforward. Again, there'll be another way to do this after the last unit of the year, so you can get ready for those of you taking pre-calc. But for now, just go ahead and plug them in the calculator and solve this way. All right, bring any questions to class, and we will see you next time.